Welcome to the lesson video on hierarchical clustering. In this video, we're going to talk about a clustering method that builds a hierarchy of groupings of data points. It's really best to understand this method by going through an example, so that's really what we'll start with. But this hierarchy of groupings of data points, it gives us a single picture at multiple levels of groupings, and it also helps us see how strongly different data points should be grouped together. So let's walk through an example. On the right-hand side of the screen, I have a plot on x1 and x2 axes, and we have 9 data points here, numbered 1 through 9, the number designating the index for the data point. On the left-hand side, we have what's going to be the output from my hierarchical clustering. So this is how hierarchical clustering starts. We look at all pairs of data points, and we figure out which 2 data points are closest to each other. And the 7 and 5 are the closest. So we start by linking those together. So that's this link right here says 7 and 5 are the closest, and we're going to link those. And now we look at additional pairs of data points or comparing data points to the clusters that we've already made. We only have one cluster here so far, but the next closest pair are 1 and 6. So that's this grouping at 1 and 6. And if you were to look at this diagram on this left-hand side, it's called a dendrogram. The location where the 5 and the 7 are linked, that is lower than the location between the 6 and the 1 are linked, because that height on the dendrogram indicates how close things had to be before they got linked together. Now we look at next levels of connecting the points and either connecting the points together or connecting them to the clusters. And there's different ways to compare points to clusters. And so if we want to compare the number 8 to this cluster with the 5 and the 7, we could compare it to the closest point in that cluster, or the furthest point in the cluster, or to the average of the points in the cluster, or we could compute its distance to every point in the cluster and take the average of those distances. For the current dendrogram that we're looking at on the left, what was used was the farthest point. So this 8, to compute the distance from this 8 to the 5, 7 cluster, we would use the distance from the 8 to the 7. The other next possible cluster would be this 4 to the 1, 6. And so the furthest point in the 6, 1 cluster is the 1. So the next grouping might be 8 to the 7, with 8 going in with the 5, 7 cluster, or the 4 to the 1. And what's going on here, the 8 is closer to 7 and 4 is to 1. So this is the next linking that occurs. The 8 gets grouped in together with the 5, 7. Then a little higher up, we get 4 linked with the 1, 6 clustering. And then the next linking that occurs is the 3 will get linked here, and he probably goes to whatever point's furthest away, maybe the 4. And then the 2 and then the 9 get grouped with the other cluster. And then at the highest level, the 2 clusters that are left get linked together. And so what we can do is look at this dendrogram on the left, and we could threshold it at different levels. So if I said I'm going to everything up to the 3, so if I set a threshold here, I would have, let me get a little bit of color that'll help me designate this. I would have one cluster that would consist of the 8, the 5, and the 7. I would have another cluster that would consist of this group, the 3, 4, 1, and 6. And then I have the 2 is a cluster by itself. And then what haven't I used for colors? Maybe this light green would be the 9, and that would be a cluster. So if I threshold at this height that we have, that I've drawn in this purple, I get the 4 clusters. If I threshold right here, I would get 2 clusters. So the 9 and the 2 would join there, and then I'd get my other group. So this would give me these 2 clusters, this lower level would give me the 4 clusters. So what we get in hierarchical clustering is this dendrogram picture on the left-hand side, and it gives us a picture of the different levels of how close things are and how quickly they get clustered. Let's walk through the definition, be a little more rigorous about what we're doing when we're doing hierarchical clustering. And so here's the algorithm description. Step 1, we have n observations, and we compute all pairwise distances between them, and we call them dissimilarities because we don't have to use Euclidean distance to compare them. But there's some measure of how far apart they are, how different individual pairs of points are. And to begin with, each observation forms its own cluster. And then we're going to iterate through these steps, and we're going to examine all pairwise interclustered similarities, just like we were doing, and then we're going to fuse the next closest clusters the way we were walking through before, and then we're going to have to recompute the pairwise intercluster dissimilarities for the remaining clusters, because once we create new clusters, those similarity measures can change. Now there's a couple of different, they're called linkages, which are the ways for computing the similarities between 2 different clusters. And so the first way to compute the distance between clusters, which is what we used on our previous example, we use the maximal intercluster dissimilarity. And that's computed by computing the pairwise dissimilarity, or we'll just call it a distance between all pairs of observations in the 2 clusters, and taking the largest of those. Single would take the minimal intercluster dissimilarity. So we would just take the smallest or the closest pairs of points between our 2 clusters. The average is just the average distance between points, and the centroid would be the distance between these centroids, right? Distance meaning whatever form of similarity we're using. Let's go through one more example. On the left-hand side, we have a data set, and on the right-hand side, we have a dendrogram using complete linkage and Euclidean distance. So complete linkage means we compute the furthest apart pair of points when we're comparing clusters. And the first dendrogram here we have on the right is with no thresholding, and everything is in one cluster. So if we don't threshold this, there's just one cluster. And the data we have on the left was generated from 3 different classes. You can tell, one green, one purple, one gold. And then the next dendrogram here, we threshold at this level, and we wind up with 2 clusters, one being the pink and one being the green, and then we have a different threshold picked, and then we see how the 3 classes that were used to generate the data fall out of the hierarchical clustering algorithm. So review of what we talked about. We've talked about hierarchical clustering. It's a method that creates a hierarchy of groupings of data points. As you go up further, we have sort of weaker and weaker linkings between our things, or things are farther apart when they get linked. And that's how you measure how close things are. When they link together at a low level, they're closer. When they link together at a higher level, they're far apart. Why would we do this? It shows how strongly different points can be grouped together, and it gives us a single picture of the level of groupings, and it can be used to threshold to create different levels of clustering. Thank you for watching.